This is a podcast by sciencemag.com.
Science Mag, come out and play. Science Mag, come out and play. Science Mag, come out and play.
Articles and other sources are directly quoted during the episode. Check the script to find out such quotes. The link to the script is in the episode's description.
Hello, dear English-speaking reading hearing listener. Welcome back to me at the Science Mag, written Science MUG, the blog / podcast / Twitter and Instagram accounts / entity behind the unsuccessful eShop Stuff and Go on Zazzle.com, which tells you science stories while rolling just to see what happens. A perfect but surprisingly less expensive than one could think replica of the dices Einstein's God actually left on the cosmic green table once done with them, and which talks to you thanks to the voice kidnapped via voodoo wire trick from a very, very dumb human, and which does all of this in English ? A language that is to proper English what twerking is to elegance. Today I'm gonna tell you the last part of a story about human placentas and plastics.
Science Mag!
A group of Italian researchers, aka the Italian brains, aka the ITVs, finds microplastic fragments that is plastic particles smaller than half a centimeter in human placentas of women in good health and who had had normal pregnancies and deliveries. The study is led by medical doctor Antonio Ragusa, head of the Department of Woman, Mother and Newborn of the San Giovanni Calivita Fate Bene Fratelli Hospital in Rome, and Dr. Ragusa and colleagues' research is told in a paper published on the science journal Environmental International. And dear listener, at the end of the episode, be sure not to miss listening the answers kind Dr. Ragusa gave to this blog's 3 questions for the oddities and bloopers, the researchers' fun corner. Okay, so people, listen the previous episodes to learn what the Italian brains did to finally make their troubling discovery. I just remind you that microplastics most probably enter human body via inhalation or ingestion, and that they are dangerous for human health and, of course, for the developing fetus. And in this 4th and final part of the episode, then, we are gonna find out how massive and widespread plastic presence in the environment be, and therefore how often and easily you humans are exposed to plastic pollution, and how harmful this kind of pollution be to life forms in general and you sapiens people in particular. Let's start with the massive and widespread plastic presence in the environment topic. In the last 70 years or so, the growth of plastic production has gone faster than that of any other human-made material, with the sole exception of steel and cement, which are widely used in the construction sector, a sector that, with the population of the world roughly tripled in the last 70 years, for sure worked at full speed and needed a lot of those 2 things. Anyway, plastics. Their usage increased about 25 times in the last 4 decades only. In 2017, plastic annual production reached 380 million metric tons and growing. In 1950, when the massive plastic production era began, it was only 2 million tons. In 2016, between 4 and 6% of all oil and gas used in Europe was used for plastic production, and up to 2015, human produced 8,300 millions tons of plastics, in doing so creating about 6,300 millions metric tons of plastic waste. Of this dizzying amount of plastic waste, only a tiny 9% was recycled, given also that the recycling thing wasn't basically a thing before the 80s of the last century, while the 12% of this mountain of garbage made of plastic was incinerated, and also incineration was negligible before the 80s, and even worse, a huge 79% of all this plastic garbage ended up accumulating in landfills or the natural environment. If current production and waste management trends trends continue, roughly 12,000 million metric tons of plastic waste will be in landfills or in the natural environment by 2050. So people, to sum up, as of 2015, the equivalent of more than 62,000 Eiffel Towers of plastic waste have been produced. You line up all those Eiffel Towers and you make half Earth's circumference. And the plastic garbage equivalent of almost 180,000 Statue of Liberty ended up in dumps or the natural environment. You pile up all those statues of liberty and you reach the top of Mountain Everest. And these landfills dump the plastic waste statues of liberty could become almost 500,000 in 2050. Now, as for the recycling thing, at present, plastic recycling only postpone rather than eliminate plastic dumping. Environmentally successful recycling, indeed, avoids primary production and landfilling of plastic. In other words, successful recycling means that for every ton of recycled material produced, a ton of brand new plastic will not be produced. And simply, this is not happening. Besides, dear listener, an actually successful recycling system is paramount, given that at present, none of the commonly used plastics are biodegradable. What a biodegradable polymer is that stuff that living things, usually microorganisms, are able to degrade into small molecules such as CO2, methane and water a hell a lot faster than common plastics. And oh pal, don't be fooled! The so-called bioplastics, or biopolymers, ain't all the same stuff, and above all, only few of them are actually biodegradable. So, all in all, folks, there's a lot of semi-eternal plastic waste around. There's so much of it, and it is so ubiquitous that plastic waste has been proposed as a geological indicator of the present proposed geological era, the so-called Anthropocene, which replaced the Holocene. Now, so far, dear listener, you heard about landfills, but plastic pollution is really everywhere, not only in the terrestrial habitats, but also in freshwater ecosystems and of course in the oceans. Indeed, plastic debris, defined as plastic items occurring in natural environments without fulfilling an intended function, well, plastic debris has been found in all major ocean basins from the Arctic to the Antarctic, with an estimated 4 to 12 million metric tons of plastic waste generated on land entering the marine ecosystems in 2010 alone. This means more than 5 trillions, that is 5 billion billions, pieces of plastic waste are sailing the ocean, with more than 80% of all this plastic pollution that has a land-based origin, being mainly stuff from construction, household goods, packaging, coastal tourism and food and drink packaging, plus cosmetics and personal care products, textiles and clothing, as in synthetic fibers, terrestrial transport, as in dust from tires, and plastic producers and fabricators, as in plastic resin pellets used in plastic manufacture. The remaining 20% of ocean plastic pollution comes from the sea itself, mostly from fishing activities, like, for example, lost and discharged fishing gears, 1.15 million tons per year from this source. But also aquaculture structures can produce significant quantities of plastic debris if damaged by storms. And there's shipping litter too, 600,000 tons per year. Besides, 94% of the plastic that enters the oceans end up on the sea floor. There is now, on average, an estimated 70 kilograms of plastic in each square kilometer of seabed. So, well, this means that basically now the ocean's floor is covered by a plastic carpet. Okay, moving on. You, dear informed listener, probably have heard of the infamous 5 big oceanic gyres in the Indian Ocean, North and South Atlantic, and North and South Pacific. Gyres that entrap islands of floating pieces of plastics. Nevertheless, mate, barely 1% of all marine plastic debris is found floating at or near the ocean surface, with an average global concentration of less than 1 kg per square kilometer. In the North Pacific gyre, it peaks at 18 kilograms per square kilometers. Therefore, there is a much lower plastic garbage concentration than that estimated existing on the beaches around the world, which is a stunning 2000 kilograms of plastic crap per square kilometer. And by the way, folks, this means that, given the numbers, to get rid of beach plastic litter and avoid like that its return at large on the ocean's waters, well, can actually be a more effective, simpler and cheaper strategy than pick up plastics already floating in the mid-oceans. Oh, by the way, to the return of the digressions, science literature is reporting since the 70s of last century that plastics are polluting oceans, but only with the new millennium the attention to the problem rose. And given oceans cover about the 71% of Earth's surface and harbor, among many other essential things, a huge chunks of humans' food supplies, well, it is definitely a good thing that attention to this problem rose. Now, dear listener, let's specify a few things before continuing this nightmarish travel on global plastic pollution, okay? Okay. Marine plastic debris and plastic litter in general can be made of primary sources of pollution, meaning they are plastics or pieces of plastics produced for a specific use and then turned into debris, and or secondary sources of plastic pollution, meaning they are microplastic produced as the result of degradation and fragmentation of bigger pieces of primary plastics. Said that, let's sum up what kinds of plastic litter you find in the oceans and where they come from. But be aware, dear listener, there's still no common ground on the scientific community about names and measures. Anyway, I refer now to what is said by the Joint Group of Experts on the Scientific Aspects of Marine Environmental Protection, the JESAMP, that is an advisory body established in 1969 that advises the United Nations, the UN, system on the scientific aspects of marine environmental protection. Okay then, according to JESAMP, the marine plastic litter is made of microplastics, plastic less than half a centimeter in size, mesoplastics, less than 2.5 centimeters, macroplastics, less than 1 meter, and finally megaplastics, more than 1 meter. Microplastics are both primary sources like resin beads, microbeads from personal care products, etc., and secondary ones like textile fibers and tire dust, etc. Mesoplastics too are both primary and secondary sources. Examples are bottle caps and various fragments. As per the macroplastics, well, they are just primary sources, mainly lost items from maritime activities or from rivers like plastic bags, food and other packaging, fishing floats, buoys, balloons, and so on. Finally, the megaplastics too are just primary sources, being abandoned gear or the results of catastrophic events. For example, rope, boat hulls, plastic films from agriculture, abandoned fishing nets and traps, etc. And by the way, dear listener, ghost fishing by abandoned or lost fishing equipment causes important losses of potential food for humans. So, people, to recap, plastic litter ranging in size from less than 5 millimeters to more than 1 meter pollutes world's lands and waters, and the issue is so huge that the United Nations Environment Programme says that plastic pollution is a problem with a scale and degree comparable to that of climate change. The result of this pollution is, for example, the existence of airborne microplastics that can be breathed in by humans and end up in their lungs, as showed by lung biopsies and as confirmed by a 2018 study that analyzed atmospheric fallout in Greater Paris, a urban area that includes, besides Paris, more than 130 towns around La Ville Lumière, with a total of more than 7 million inhabitants and a surface of about 800 square kilometers. Another example of plastic pollution pervasiveness, dear listener, is a 2019 study that finds an average of 20 microplastics ranging from 50 to 500 micrometers in size of 9 plastic types per 10 grams of human stool in each of the 8 healthy men, aged from 33 to 65 years, coming from Europe and Asia. This study, therefore, shows that people all around the world involuntarily ingest plastics from different sources. But what can be the sources of such plastic ingestions? Well, Paul has said in the previous episode, a very big one is domestic dust. Then there's, of course, the food chain. Microplastics can bind to micro and macro algae, seaweed, and are gulped down by a wide range of living creatures. Plastic is consumed by zooplankton, which mostly eats phytoplankton and in turn is eaten by larger animals like whales. So for starter, there's plastic in the diet of stuff that is basically the bottom of the marine food chain. For instance, the Pacific krill being the most well-known kind of zooplankton, has been found to ingest its staple egg as well as plastic bits of about the same size range with no evident foraging bias. Moreover, there are plastic eaters also among worms, crustaceans, mollusks, meaning shellfish, fishes like, just to mention two of them, sardines and sprats, turtles, birds and cetaceans. In total, by 2017, more than 220 different species in nature have been reported to consume microplastics. But dear listener, let's have fun, so to speak, and dig deeper into details. As just for the marine environment, for instance, microplastics have been found in shellfish and fishes of commercial interest as food from China, Hong Kong, Indian coast, Oceania, South Pacific, Persian Gulf, Red Sea, Middle East, Europe, Mediterranean, Baltic and North Seas, Atlantic Ocean, South America and USA. These species of plastics have sizes ranging from more than 9 micrometers up to more than 20 millimeters, and they go from fibers to film, pellets, fragments, sheets, filaments, fishing threads, styrofoams, nylon and hard plastic. And these microplastics have been found in the muscle, skin, gut, soft tissues, liver, stomach, gills, hepatopancreas, valves and the whole body of these animals. And in some species of shellfishes, the microplastics level arrived to be of almost 60 particles per individual, with cases in which the 83% of the animals species individual tested had microplastics in them. And in fishes it gets worse, since the maximum number of microplastics found was 552 per individual, with several species with 100% of their individual that tested positive for microplastics presence in them. How can it be, you may ask, dear listener, that it be so common that the plastics end up inside all these animals species? Well, pal, microplastics can be easily uptaken by many types of marine organisms. The most common, but not the only one, entrance way is ingestion, since the plastic fragments can be mistaken for a prey. Moreover, plastics can penetrate into the animals via passive water filtration or deposit feeding activity. That is, that feeding strategy adopted by those animals, like some marine worms, which move along the surface or burrow within soft sediments and ingest some parts of the sediments, digesting and assimilating like that some of the non-living and living organic matter. And remember what I said before, dear listener, there are 70 kilograms of plastic debris per square kilometers on the seafloors of the globe. To be crystal clear, people, plastic fragments have been found in seafood sold for human consumption as well as in fish and shellfish purchased from markets. Moreover, besides wild animals, also the ones grown in aquaculture systems swallow plastics. For instance, bivalves cultured in estuaries and coastal lagoons are prone to ingesting microplastics because the plastic pollution of water and sediments of many such areas. Besides, aquaculture systems feed their fishes, shrimps and other farmed species with materials obtained from animals that in turn may be polluted by microplastics. So, false. To recap, humans eat fish, crustaceans like shrimps and bivalves like mussels and oysters, and all this food has plastic in it. Therefore, in the end, humans eat plastics on a regular basis. Okay, now I know what you may say. Oh, no big deal, I rarely eat stuff coming from the seas anyway. Well, pal, sorry to break it to you like that, but microplastics have been found in a whole lot of other stuff people routinely eat and drink. Let's see. Beer, 100% of the sample tasted up to 109 fragments per liter. Honey, 100% of the sample tasted up to 166 fragments per kilogram. Sugar, 100% of nearly all sample tested, up to 217 fragments per kilogram. Salt, 100% of a sample tested, up to 681 fragments per kilogram. Drinking and mineral water, 100% of the sample tested, up to 251 fragments per liter. And tap and bottled water, 81% of the sample tested, up to 61 fragments per liter. The size of the pollutant plastics found in these food and drink products ranged from 1 micrometer to 5 millimeters, and they comprised fibers, granules, pellets, fragments, sheets, and films. Finally, like for sea-related food, all in all, these plastic polluted food and drink products came from all around the globe. China, India, Japan, Vietnam, Thailand, Malaysia, Indonesia, Australia, New Zealand, South Africa, Uganda, Morocco, Turkey, Lebanon, Iran, Europe, Switzerland, Scotland, Russia, Canada, USA, and Mexico. On top of all of these, the other scary thing here is not only the global size of the problem, but also the fact that plastic pollution can easily cross food webs. Therefore, there are risks of accumulation of such plastics and an increased risk of toxicity, above all for top predators. And the last time I checked, dear human listener, well, you are the top predators of all. And at this point, done with the deep exploration of the how bad and widespread the plastic pollution issue is, well, folks, let's go and answer to the second question mentioned in the beginning of the episode. That is how harmful plastic pollution is to life forms in general and to you sapiens people in particular. But the answer, dear folks, after the commercial break.
Plastics, 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 plastics. You have been just presented the acoustic rendition of Global Plastic Pollution, sponsored by the DWMHPPCFSW, the Dude We May Have a Plastic Problem Committee for a Safer World.
So, dear listener, now we go with the effects, potential and found, of plastics on living things. But first, let's add something important. Plastics can do harm not only by physically blocking or damaging the feeding appendages or digestive tracts of the animals, or entrapping them like dolphins or seals entangled in fishing gears, or filling their stomach with something that isn't food. Think, for instance, of that of dead albatross full of plastic objects. Plastics are dangerous also in a more subtle way. Microplastics, but also mesoplastics, indeed, in the oceans, may be receptacles of persistent organic pollutants, POPs, like phenanthrene, for example, a white-yellow crystalline substance that you can find in fresh crude oil and that is toxic to crustaceans, fish mussels, gastropods, and marine diatoms, and that is also reported to be a potent inhibitor of gap junction intracellular communication. Listen to the last episode about this kind of cellular communication, and the human skin photosensitizer midalargen. Now, these POPs, these persistent organic pollutants like phenanthrene, are universally present in seawater, but usually at very low concentration. Nevertheless, they are picked up by plastic debris, which, like that, concentrate these pollutants to levels several orders of magnitude higher than those of the waters. And when the sea creatures, some of which later become humans' food, ingest such POPs-enriched plastics, well, the sea creatures get very high dosages of these nasty pollutants. But there's more! Oh yeah! Microplastics are vessels and human bodies' Trojan horses, also for plastics' very own additives, namely chemicals added on purpose during plastic production, like, just to mention two of them, plasticizers, used since the 1930s of the last century to soften and provide plastics with flexibility, and phthalates, used to improve flexibility and durability. And it is worth to know, dear listener, that microplastics can contain on average 4% of additives. But besides the above mentioned stuff, microplastics surface during their life cycle may harbor and be carrier also of environmental pollutants, one example are toxic metals like heavy metal mercury, of exotic invasive species, and even of pathogens like disease disease-carrying bacteria like those of cholera, just to mention one. Okay, all of these things said, let's see what are the nasty effects of microplastics on animals in general. The negative health effects somehow linked to microplastic exposure of animals are mortality, increased immune response, decreased predatory performance, changes in behavioral responses and reduced swimming performance, decreased food consumption, weight loss, decreased metabolic rate, reduced allocation of energy for growth and decreased growth rate, decreased fecundity and fertilization, decreased and larval abnormalities, depletion of energy reserves. Some marine worms, for example, in a lab experiment suffered a stunning 50% energy depletion, and negative impacts on subsequent generation, neurotoxicity and intestinal damage. And once heard all these beautiful things, let's hear now the negative impact microplastic have specifically on humans, okay, dear human listener? Okay, buckle up. But folks, bear in mind that negative effects of microplastic on human health are still under investigation and are still controversial and not well understood. So emphasis on the may and could from now on, okay? Okay, let's begin. If inhaled or ingested, microplastics may accumulate and exert localized particle toxicity by inducing or enhancing an immune response. More specifically, microplastics and nanoplastics, meaning plastic smaller than 1/10 of a micrometer, although there is still a debate about nomenclature, as said before. So, microplastics and nanoplastics could lead to immunotoxicity and consequently trigger adverse effects, meaning immunosuppression, immune activation, and abnormal inflammatory responses. Micro and nanoplastics could be cytotoxic, meaning they have the potential to be toxic at the cellular level. Moreover, the above-mentioned phthalates may have negative effects on testicular development, and plasticizer and heavy metals associated with microplastics and plastics in general are among the endocrine disruption chemicals, meaning compounds that interfere with any aspect of endogenous hormones, including their production, release, transport, metabolism, binding, action, or elimination. Endocrine disrupting chemicals can play a role in decreased fertility, decreased semen quality, increased birth anomalies, hormone-related cancers, problems with neurodevelopment, metabolic diseases like obesity and diabetes, and other funny stuff. All in all, the compounds microplastics are vessel of may be, among other things, carcinogens, endocrine disruptors, neurotoxic compounds. Now, it is to say that, in general, humans get rid of more than 90% of the ingested microplastic via feces. So next time you buy, dear listener, a fake plastic poop, well, think of this. Anyway, only the pieces of plastic smaller than 150 micrometers may translocate from the gut cavity to the lymph and circulatory system, causing systemic exposure. However, the absorption of this microplastic is expected to be limited to less than 0.3%. Only microplastic with sizes smaller or equal to 20 micrometers would be able to penetrate into organs, while the smallest fraction, between 0.1 to 10 micrometers, would be able to access all organs, cross cell membranes, the blood-brain barrier, and the placenta. And voila, dear listener, back to the placenta. But before seeing what are the potential effects of microplastics also on the developing fetus, let's conclude the tale of Dr. Ragusa and colleagues, aka the Italian brains, aka the ITBs study. The Italian researchers, I remind you, find microplastics ranging from 5 to 10 micrometers in size in human placentas, and they find them in almost all the samples tested, 6 out of 8, meaning 2 samples tested negative. So why is that? Well, the ITBs say that various physiological conditions and genetic characteristics of the pregnant women, together with their different habits and lifestyles, may have determined the rate of success of the microplastic to cross the placenta. For instance, the ITBs say microplastics' degree of success in their trip across the placenta can be linked also to drug-transported proteins and the fact that their presence and activity level are strictly regulated by multiple factors and vary both within human population and also during gestation. Okay, folks, done with the pinpointing this, let's find out what are the Italian brain's thoughts about the potential impact of microplastics on a developing fetus. Dr. Ragusa and colleagues state this: potent Potentially, microplastics and in general microparticles may alter several cellular regulating pathways in placenta, such as immunity mechanisms during pregnancy, growth factor signaling during and after implantation, function of receptors governing maternal-fetal communication, signaling between the embryo and the uterus, and trafficking of uterine immune cells during normal pregnancy. All these effects may lead to adverse pregnancies outcomes, including fetal growth restriction and preeclampsia, namely a pregnancy-related high blood pressure disorder in which the mother's high blood pressure reduces the blood supply to the fetus, which may get less oxygen and fewer nutrients. So, dear listener, that's the full story of a bunch of researchers and their fascinating scientific microplastic placenta-related quest. Now, as anticipated, Dr. Ragusa has kindly agreed to answer a few questions this dumb blog asked him, and now I'm gonna read you such answers. So, Pips is asking the questions, and I'm reading Dr. Ragusa's answers.
Dear Dr. Ragusa, what is the strangest thing happened to you and colleagues during the making of your study described in the episode?
One of the hardest things in the study was organizing the plastic-free placentas harvesting protocol. Eventually, when everything was ready and we had the first placenta arriving, the mother was giving birth, we realized that there were no plastic-free containers in the hospital. So we stopped everything and lost the placenta of the first donor mother. I tried to look for plastic-free containers from sanitary material suppliers. I got help from my hospital pharmacist, but we weren't able to find them. It seems incredible, but plastic is everywhere. So I tried to look for plastic-free containers outside the sanitary circuit, and finally, in a suburban shop in Rome, run by a couple of Chinese shoppers, I found some small glass salt shakers with metal cups. So I bought 30 of them, with great joy of the lady who sold them to me, who asked me if I had a restaurant. I jokingly replied that I did not manage a restaurant, but that I was a scientist, and thanks to those salt shakers, I would have gotten the Nobel Prize. So the seller wanted to take a photo with me, future Nobel Prize laureate, thanks to her.
Dr. Ragusa, besides for having the possibility of doing and witnessing strange things, why science?
Science today is the equivalent of art in the 16th century, during the Renaissance. Back then, and for many centuries on, if you wanted to discover the truth and question yourself about the important things in life, then art was the answer. Men of the caliber of Leonardo, Raphael, etc. are the testimony of it. Today, this role of discovery and innovation rests with scientists.
In such hard times, Doctor, that I imagine for a person in your line of work can be even harder. Is there something that makes things lighter for you, or at least a bit less difficult?
Yes, the profound awareness that everything will end, and if everything doesn't end, then you yourself eventually end. I said profound awareness, which is different from having an idea of things. It means that this concept is for me a rule of life, not a vague idea.
Well, Doctor, thank you for everything and good luck.
Okay, folks, that's really it for this episode and research paper. Or is it not? Just think, dear listener, you spent 4 episodes hearing of plastic. Plastic here, plastic there. But in the end, are you sure you really know what plastic actually be? Well, in case you don't, here I am for you, pal. Plastics is not one single material. It's a whole bunch of them derived from organic products such as cellulose, coal, natural gas, salt, and of course crude oil. As said above, in 2016, in Europe, between 4 to 6% of all the oil and gas was used to produce plastics. Now this episode exhausted me, so I will use a quote with other quotes within for a more specific portrait and definition of plastics. The main quote is from a 2017 paper by De Souza Machado et al. All plastics are characterized by high plasticity. It has the capacity to change in shape in response to applied forces, at least at one point of their manufacture. More than 80% of the plastics produced are thermoplastics, like polyethylene or PVC, while the other 20% are thermosets, like silicone or polyester. Thermoplastics are obtained through polymerization of monomers into high high molecular weight chains known as thermoplastic polymer. End of quotes. The following and final step of plastics production is to modify the physical properties of the polymer matrix, like melting and pelletization, and its chemical properties too, meaning the polymer matrix is mixed with the already mentioned additives such as plasticizers, antioxidants, clarifiers, colorants, etc. So, pal, to sum up, plastics products have a pretty complex chemical composition, and malleability, low cost, durability, and versatility are their trademarks features. Okay, folks, it's really all for now. See you next time, and till then, take care. And if you spare some time and feel like doing it, please subscribe and or rate this podcast, and or leave a comment on the blog, and or take a tour on my Stuff and Go e-shop on Zazzle.com so you can see if there's something you like, and or make a donation clicking on the donate button on this dumb blog homepage. Ciao!
Science man, come out and play. Science man, come out and play. Science man, come out and play.
This is a podcast by sciencemag.com.